Hey guys, welcome to the CS Classroom. So what we're going to talk about today is pseudocode for the A-level computer science exam. Now, technically, all pseudocode really is just words that are used to plan or describe an algorithm that will later be written in an actual programming language like Python or Java. But weirdly, on the A-level exam, it kind of takes on its own role as a programming language in which we're writing code in a specific syntax that will never actually be implemented in a real programming language. It's weird, but still, this means that you need to learn A-level pseudocode as if it were a programming language. And to do that, we're going to go through 10 tasks that are based on A-level problems that I've seen from past exams. Now, these tasks are going to cover variables, conditionals, loops, 1D arrays, 2D arrays, custom data types, procedures and functions, strings, text files, on object-oriented programming. Now, this tutorial is not meant to teach you programming. It's meant to teach you pseudocode. So if you want to learn these concepts, you need to go through some sort of tutorials, or you need to make sure that you know Python and Java fairly thoroughly first, and then tackle pseudocode, because I'm really just focusing on the syntax here. Now, ideally this will be a two-part series, with part 1 focusing on this stuff, and part 2 focusing on implementing abstract data structures like linked lists, stats, stacks, etc. in pseudocode. But I'm only going to create a part 2 if part 1 is successful. So if you find value in this video, make sure to like the video and subscribe to the channel. In this video as well, we'll be going through the differences between pseudocode and Python or Java. It's more likely that you're familiar with a real programming language like Python or Java. So I want to make sure that you understand the differences between those and the syntax and usage of different commands in pseudocode. That being said, let's go ahead and let's get started. Okay, so let's get started with our first task, which is going to be calculating the volume of a sphere. Now, the first thing we want to do is we want to get the radius of a sphere from the user. So to do that, we need to declare some variables first. So to declare a variable, we're going to do declare. We're going to create one variable for volume, and we're going to create another variable for radius. Now, you don't really have variable declarations in Python, but in Java you do. And basically what a declaration is just creating a variable, not even initializing it. So we're going to use the declare keyword in all capital letters, the name of our variable, which in this case is going to be volume, and then the data type, which is going to be in all capital letters. And the name of the variable and the data type will be separated by a colon. Now, real I don't think I've ever seen real in Python anywhere. I mean, we don't really work with data types as much, but real basically represents a decimal. We can also have integer, also have real. Integer can be another option. Char for character. We can have strings, and we can also have booleans as well as dates, strangely, which is just like literally a date. But you can only have one data type at a time. Now, because these are both of the same data type, we can actually just get rid of this, and we can say declare volume comma radius with real data type. That means we can create both of these in the same line because they have the same data type. So declaring our variables was the first step. Now we actually want to get the radius of the sphere so we can calculate the volume of the sphere. So to do that, we're going to do input radius. And what this input command is basically symbolizing right here is this is basically simulating allowing the user to type in a value into the terminal or the console. Obviously, that's not going to happen here because this is pseudocode and we're not executing this. We're just writing this on paper. But that's what's happening right here. And then once the user enters their text, that's going to be stored in the radius variable. So you're going to have an input command and then the name of the variable in which that data is going to be stored right after. So we're getting our data from the user. We're getting our radius from the user. Now we want to go ahead and calculate our volume. So we're going to do volume, and then not equals, but an arrow. So the equal sign is used universally in Java and Python, but in pseudocode we're using an arrow for some strange reason that I frankly don't understand. But it is what it is. So now we're just going to do 4/3 for 4 divided by 3. times 3.14. We don't really have access to pi. If we do, it would probably be given to you in the question, but I haven't seen it so far. And then we're going to multiply that by radius, which is what we got from the user. So we have volume, and then we can go ahead and output our answer to the console. We can do output volume, and this is simulating actually like printing something out to the terminal or the console. So to summarize, we declared some variables with a specific data type. We got user input from the console, which you will actually have to do on pseudocode questions. We calculated the volume using our user input as well as some other numerical values that were part of that formula, and then we output that to the user. There you go. That's your first pseudocode problem. Now we're going to make it a little bit more complicated by working now with conditional statements. So with our next task, what we're going to do is we're actually going to create a calculator. So let's go ahead and get started. The first thing I want to do is I want to declare some variables. So I'm going to declare the first value, the first numerical value, and the second value. And those are both going to be decimals, so those will have a data type of real. Now next, what I'm going to do is I want to get this operation, and that means I'm going to get a string that has one of these symbols. So I'm going to declare operation, and that's going to have a data type. Actually, I'm going to make that lowercase, and then that's going to have a data type of string. So technically, it doesn't really matter how you name your variables, but generally in pseudocode, the best practice is to have so basically you're going to have your first letter being uppercase, and the rest is going to be lowercase. And then if your variable is made up of 2 or more words, then the first letter of each word is going to be uppercase. So for example, right here, the F here was uppercase, the V here was also uppercase. In an operation, we just have one word, so just the first letter is going to be uppercase. Now this is similar to camel case in Java, except like in camel case, the first letter of the variable is always lowercase. So it's similar but different. So next what we want to do is we want to get these as input. So I'm going to get the first value as input, then I'm going to get the operation, and so we'll call it operation, and then I'm going to get the second value as input. So the idea is that you'd be inputting 1, your operation, and then, or like you'd be inputting your first value, the operation, and then your second value. So now what I'm going to do is I'm just going to use a bunch of if statements in order to calculate the result of, or any possible result of these operations. So I'm going to start with addition. So I'm going to say if operation equals plus then actually I want to create another variable for the result, so I'll add that up here. I'm going to say result is going to be equal to first value plus second value, and then end if. So a few things to like point out right here. First, I should capitalize that, but also here, like this is a Boolean operator, or one of our Boolean operators. And normally in pretty much every programming language I've worked with, this is 2 equal signs. For some reason in pseudocode, it's just 1 equal sign. And I guess that kind of makes sense because here we're using an arrow instead of an equal sign. Some other types of Boolean operators we can use are going to be like greater than or equal to, less than or equal to, like greater than, less than, and strangely, not equal to. So if we wanted to check if the operation was not equal to the plus symbol, then we do something like this, which is weird because normally in like Python, it's like that, or Java as well. For some reason we use this. So just keep that in mind if you want to use the not equals Boolean operator for something. Anyways, getting back to our question. So that handles the plus operation. We can just kind of copy that for all the other operations. So we can do minus, multiplication, and then division. And then we can just kind of change our actual arithmetic operators accordingly. So we can do minus, times, and division. Now, once we've done that, we could just go ahead and we could output our result like so. One thing I do want to do is I want to handle a case in which an invalid operator is entered. So basically how this code works is these values are being entered. We check is operation equal to plus. If not, do nothing. Is it equal to minus? If not, do nothing. Is it equal to multiplication? If not, do nothing, and so on. But when we get to division, that is basically the last time we're doing a check. So in order to handle an invalid operator, like a question mark or something, then we could just do it else output result. Well, actually, we can just set result rather than doing that in the same line. We could set result to a string. Actually, that's not going to make sense because result is already real. I guess we can just output invalid operator. And we can set result equal to 0 as just sort of a placeholder value. It's not really clear what would happen if we just printed out result without doing anything. Like, it's just not a part of like any of the guides that I've seen. So, I mean, arguably if we just did this, then we just have like a blank, or just nothing would get printed out, which maybe is actually preferable. Anyways, this is an example of using an else statement, which you've probably seen in both Java and or Python if you use it. Now, we do have if-else statements. But one thing that we don't have is we don't have like else if, which is something that we have in Java and in Python as an elif. So one way we could do this entire thing is we could do if operation equals plus, then, and if it's not, else, try multiplication. And if that's not valid, then try this. And if that's not valid, then try division. And I guess we could probably actually just copy all of this right here. And arguably this is more efficient because once we hit any of these operators, then we don't go any further down into the if statement block. Versus here, we're actually, in our previous example, we were checking every single block. And I would never do this because this is kind of just stupidly complicated. We'd have to do like end if, end if, end if. But if you really like, if you had like a complex problem where you felt like you needed to chain together a bunch of else statements, this is how you would do it. You can't just do else if, you have to have else, then you have to have an if statement, a full if statement inside. Now, as you can see right here, I use tabs, and it's not like necessary to do on the exam, but it definitely makes your code a lot easier to read. However, just to make it clear, it's not going to affect the operation of your pseudocode statement the same way as it would in Python or something like that. But anyways, I hate this, so I'm just going to get rid of all of this. I'm going to do the best thing ever, which is a switch statement. So a switch statement kind of is just shorter than everything else. We're going to start a switch statement by doing case of, and then we're going to put in operation. And then we can do plus result, first value, plus second value. Let's copy that. Minus, minus, multiplication, multiplication, division, and division. And basically what this does, we actually need to do end case right here. What this does is, this is kind of awesome because what it does is it takes whatever variable we specify right here, And then based on different cases or different possible values of that variable, it carries out a certain operation. So it's like having 4 if statements, but in a much more compact and easy to read format. Additionally, we can also do otherwise. So if the value of operation doesn't fit any of these, we can do otherwise, and then we can say actually output, so we can have whatever code we want to execute right after. And yeah, so we can say output invalid operation. And then we can go ahead and output our result regardless. Or we could have even output right here. We could have just output the result of this right here. So generally with case of, you're going to have your operations on one line, but you could even do something like this if you wanted and include a longer block of code for each option. So that's basically all the conditional statements. One thing I want to do is I actually want to show you another example of the if statement, or of the switch statement, that can be really useful. Now we're going to solve a slightly different problem. We're going to get a grade from the user. So basically a grade from 0 to 100. And then based on the grade, so based on whether the grade is from 90 to 100, 80 to 89, or 70 to 79, we're actually going to print out a message. So we'll get rid of all of this. We don't really need, all we need is one variable, which is grade. And then we can get rid of this, input grade, get rid of this right here. And basically how we're going to handle this is we're going to change this to grade because that's going to be our input to the case. That's going to be the variable that we analyze in our Swift statement or Swift block. And then we can say 90 to 100 with 2 capitalized, output good. Not excellent because we have Asian parents, so or I do. 80 to 89. Okay. 70 to 79. Again, to my parents, this would probably be a fail, but we'll just say not bad. Hashtag mental health. And we'll just have an otherwise block and just say otherwise, if you don't get that, you are a failure. This is an example of a different kind of switch statement that basically allows us to handle numerical ranges. Now, the last thing I said I would do is actually just create a function. So we're going to kind of go back in time here. We're going to go back to our previous task, and I actually want to turn this into a function. So to be clear, a function allows us to get some parameters and then output a resulting value. So I want to create a function called calculate. And in that function, I want to take 3 parameters. I'm going to take a first parameter just called first. That's going to be a real. I'm going to take a second parameter called op, which is going to be a string. And I'm going to take a third parameter called second, that's just going to be a real. And what we can actually do, so this is basically our method definition. We have a function keyword all capitalized. We have the name of our function. We have the parameters with their data types. Then we're going to have another colon, and we need to actually specify what kind of value is going to be returned, which is kind of similar to Java. We're going to say this is going to return a real, so it's going to return a decimal. So once we've done that, we can actually just go ahead and transplant this in here. So I'm going to go ahead and just do some tabbing to make everything like super clean. And we're obviously we can keep this the same. Okay, I'm going to keep result, but I'm going to get rid of this. So I don't need to declare result again because I already have result right here. And the big difference between like Python and Java is normally when we create methods, we try to kind of isolate, we try to create variables and isolate them in our methods. So ideally, if we just had this function, we wouldn't have result declared outside our method, but we'd actually have it inside. And that's just something we normally do in like Python and Java, right? And part of the reason for that is a concept called scope, where if we create this variable inside here, we can't see it anywhere else, and things don't get messy. Like, it doesn't interfere with any other code we're writing. But we don't care about that in pseudocode, so we can have variables that are declared outside a method, and we're still going to use them inside our method. In fact, that's the most common thing to do it. By the way, I'm sorry for using the word method. Method is the same thing as a function. Sorry if that was confusing. Anyways, if that whole explanation on scope and using things inside and outside methods was confusing, don't worry about it. We're going to use result in here. Anyways, moving on, we can do all of this. We're going to change this to first to correspond to our parameters. So we'll do that right there. And okay, that's going to work. Got this. So we will return result. Actually, not from inside the switch statement, but right here. We're going to go ahead and return our result. Then we'll say end function to close out our function. And then if we want to call this function, what we can do is we can do calculate first value, operation, and then second value. And that's how you do that. Although, you know, honestly, like, I would actually just rather do something like this, just have the result in here and then declare it. I think that is actually the cleaner way to do it and just a less confusing way, because we don't really need the result outside the function. I mean, we can create this variable and just use it in here, and then we can have something else. Like, so for example, right here, we could have calculated result, and then we could handle it out here. Because in fact, when we do run this function, we are going to be returning a value, which does need to be stored in a variable. So actually, I think this is the ideal way to do it. I create a variable that only is going to exist inside this function. I create another variable here to store the result of the function. Okay, so before we finish off this section on conditionals, what I do want to do is I want to highlight a potential error here. So if we input op and op is not one of these 4 symbols, it's an invalid operation. And in that case, we'd output invalid operation, then we'd return result. But we haven't really initialized result, so in this case, with the code as it is, we would actually get an error. So what I actually want to do is I want to go ahead and I want to initialize result. So I'm going to initialize result to 0. And that way, we would end up returning 0. So if we have an invalid operator, so if we have something that's not one of these 4, we'd return 0, but we'd also output invalid operation. So the user would know that the answer is not 0, but that a legitimate operator was not typed in. Now I want to point that out because if we do return a variable that has no value, that's not even been initialized, then we are going to get an error. And I know the error is like purely theoretical, but still you're basically writing incorrect code. So that being said, that is conditionals. Let's move on to loops. Okay, so now in this next set of tasks, we're going to be focusing on loops, and we're going to do a fairly simple example because we're not working with arrays yet. So we're going to write a for and while loop to output all of the odd numbers from 0 to 20. We're going to do the same with a repeat loop, which is important because this repeat construct doesn't really exist in Python or Java. Then we're going to wrap a repeat loop in something like a procedure, which is similar to a function, but it just doesn't return values. So we'll start by writing a while loop. The first thing we need to do is declare a counter. So we're going to say we're going to declare an integer, and we're going to set that equal to 1 because this is going to be the first odd number. Then we can just do while I is less than 20. Output I. And then I equals I plus 2. then we can go ahead and end that while block. Pretty straightforward. That's pretty much the syntax, just while the Boolean expression, whatever code we want to loop through, and then we're just going to end that block right there. Now to do the same thing with a for loop, we can just do for. So we'll use a different variable. We can do for counter, and we can start that counter at 1. Now we're using this variable counter. I'm going to make this actually lowercase right here. And the difference between the while loop and the for loop is that we don't really need to declare our counter variable. So here we declared I and then use it in the while loop. For the for loop, we can just put this in here and we don't need to declare this above. So we can do counter I. That's just going to be 1. We'll say 1 to 20. And then each time we're going to step 2. So that means our counter is going to run from 1 to 20, but we're going to move by 2 each time. So we'll go from 1 to 3 to 5 to 7, etc. Now we can go ahead and output, or yeah, we can just go ahead and output counter here. And then importantly, we're going to do next followed by our counter. So this next, we're not going to have an end for, we're just going to have a next at the end of our for loop block. So we've got our counter right here. We have the numbers are moving between, and then we have how much we're going to step each time. Now, the next variation we're going to do is going to be our repeat loop. So with repeat, we do need to declare a variable again. I'm just going to go ahead and I think I'm going to get rid of, well, I'll leave the while here just for reference. We'll declare j as an integer that's going to serve as our counter. Then we can do repeat output j. I need to initialize j first. Let's say j is going to be 1. We'll output j, and then we can say counter is going to be counter plus 2. And then we're going to have next followed by our condition. So while counter is less than 20, it could be less than or equal to 20, continue to go. So this is a little bit more like a while loop. It's just that our Boolean expression is going to be at the bottom here after a next command. So yeah, right here we've got our while loop, we've got our for loop, and we've got a repeat loop right here that we can use. Now, I wanted to show you all of these, but I would be very surprised if you decide to use anything except for the for loop. And that's even on the mark schemes for the A-level exam, that's one of the most common constructs that I've seen. Now, the last thing I want to do is I want to create a procedure. So I'm going to get rid of all of this for now. I'm going to wrap this in a procedure. Go ahead and tab this. And then we're going to have procedure. We'll call this procedure odd. And we're not really going to have any parameters, although we could if we wanted to. And then end procedure. So right here, notice we don't have any return statements. All we need to do is just output something. And even if we didn't, it wouldn't really make much of a difference. So that's just us creating a procedure. And then if we wanted to use that procedure, we need to use the call keyword. We can do call odd. And again, to be clear, I just chose not to use parameters, but if we wanted to, we could do that. So anyways, that's loops. Let's go ahead and let's move on to arrays, because that's really where we tend to use loops in more complex situations. So the first thing I want to do is I want to create or declare an array, which is similar to declaring a variable, but a little bit different. So we're going to say declare Celsius temps, that's going to be the name of our array, colon, and then we're going to say array 1 to 6 of real. So that means that our indices are going to go from 1 to 6 rather than beginning at 0 like we would normally do in Python or Java. Now, I didn't really necessarily do this because I just felt like it. Generally, most of the A-level code will involve indices starting at 1. So you might as well just do it. And we're saying that every element in this array is going to be a real type. We're also going to declare another array. So we're going to declare Fahrenheit temps. And we're going to make that an array of the same size. And remember, we're going to be converting everything in Celsius temps and putting it into Fahrenheit temps. So now we've done that, I want to go ahead and just put some value in every single element in this array. So I'm going to try to make this as untedious as possible. We'll start with Celsius temps 1, and we'll give that like 21. And then I'm just going to copy paste this like 6 times. So 1, 2, 3, 4, 5, 6. There's not really like a faster way to do this. So you're kind of just going to have to write things out. But the good thing in the exam is they're never going to ask you to just like initialize the elements or initialize the elements at indices for like an array with 20 elements in it. So this is really just for demonstration purposes. So we've got this, and now let's do some work with it. So first thing I want to do is I want to print out all the values in this array one by one. So I can just do for I, 2, 6, and then output Celsius temps, I. And then next I. And that's pretty much it. I gotta put 1. So this is just hitting every index, 1, 2, 3, 4, 5, 6. And then each time we're going to output Celsius temps, or whatever is at that particular index. Our counter is going to be I, and we have that right here in the brackets for our Celsius temps array. Now, if you want to do something a little bit more complex, we're going to convert each value to Fahrenheit and then store it in a new array, which is going to be our Fahrenheit temps array. Sorry for my atrocious spelling. So what I want to do is first I'm going to declare a variable we're just going to use for our calculations. And I'm going to say declare Fahrenheit real, because this is where we're going to store our converted value before we put it in the array. So I'm just going to say for I1, basically the same thing as above, to 6. We're going to output, well, actually we're not going to output that. We're just going to say Fahrenheit is equal to Celsius temps I times 9 divided by 5 plus 32. That's the formula for converting from Celsius to Fahrenheit. And then we're just going to say Fahrenheit temps I, square brackets, I is going to be equal to Fahrenheit. So really, even the simpler alternative would have just been to just not even use the Fahrenheit and just do this. And then next, and then I. So in this scenario, we could just get rid of this even. And yeah, so that's it for creating a Fahrenheit array full of Fahrenheit temperatures. The next thing I want to do is actually just calculate the maximum temperature, the max in the Fahrenheit array, or Fahrenheit temps array. So basically what I want to do is write down here, I want to, so we have this Fahrenheit temps array. I want to calculate the maximum in this array. So I'm going to go through that array. So basically like the same bounds, the same like loop bounds, like 1 to 6. I'm also going to create a variable declare max temp. And that's going to be a real because we're working with decimals here. And I'm going to initialize that. So I'm going to say max temp is going to be the first element of the Fahrenheit temps array. And then I'm going to say, so you have the same loop. And inside here, I'm going to put an if statement. So I'm going to say if Fahrenheit temps I is, so if any element is greater than the max temp as it is, then we're going to change our max temp to whatever that element is. And then end if right in there. And I thought this was good to show because this is a good example of using an if statement within a for loop, which is something you're going to be doing super often on the A-level exam. So yeah, like once we've done this, yeah, basically if we output max temp, then we're going to get whatever the maximum was. If you wanted to calculate the minimum, on the other hand, it's really simple. It just involves reversing the sign. So we could just say min temp, min, if Fahrenheit temps is less than min temp. So we're really the only change is switching the inequality sign. Then min temp is going to be Fahrenheit temps. So this way we're going to consistently have whatever the lowest temperature is being stored in min temp, and then just output that. It's really a very similar type of problem. Yeah, that's about it. So this was dealing with 1D arrays. We're going to have another example that's going to be dealing with 2D arrays. But yeah, I would say like just pay attention to this one because a lot of A-level questions are going to be more complex than this, but you are going to be doing a lot of work with if statements inside of for loops, particularly when you have this sort of when you have a lot of code inside different blocks. Make sure to keep it well organized, and that's basically how arrays work. So now let's move on to 2D arrays. So this is what we're gonna do. Create a 2D array with 3 rows and 4 columns. Write a procedure to print out all the elements in a row based on the index. Write a function to calculate the average of all grades, and then write a procedure that outputs the position of a specific grade in a 2D array. Let's get started. So the first thing I want to do is go ahead and declare this 2D array. And we can do that like this: declare grades array 1 to 3 for our row, and then 1 to 4 for our columns of integer. So they're all going to be integer type. I know I guess grades could potentially be decimals, but we're just going to keep this integer type. And then we're going to write our first procedure to go ahead and print out all the elements in a row. So we're going to do this based on, actually I think I want to change this because what I want to do first is just print out all the elements in a 2D array. So let's just say procedure print array, and then we can do, we're obviously going to have a set of nested for loops. So let's say for I from 1 to 3, and then for j from 1 to 4, output I j. Then we're going to go ahead and close this out with next j and next I. That would be the end of our procedure, which we could just call, okay, wait, this output ij doesn't make sense. We need to say output grades ij. And then we could just call print array. If we wanted to print out like so initially we were talking about printing out all the elements in a row. So what this would be doing is, so basically that means that, for example, like I haven't created this 2D array, but mainly because it's really tedious. But for example, we'd want to print out all of the grades in the first row at index 1 or the second row at index 2. That could be pretty easy. We could say row integer, and then we could say output all the grades at row j. We already know what the row is, so it's going to be whatever is put in as the parameter, And then we'll just print out everything from in that row, which is going to be from 1 to 4. So yeah, 1, 2, 3, 4 at those indices. In this case, we have a parameter, so we might just put in something like that. So let's go ahead and let's write a function to calculate the average of all grades in the 2D array. So we're writing a function this time, not a procedure, but I'm going to go ahead and actually just go back in time. So we're going to be doing basically what we did right here, except we're going to be adding to another variable. I'm going to change this from procedure to function. So function sum array. We're not going to have a parameter. We're going to declare a variable. We will declare sum as a integer. I guess it's an average. So we're going to declare a sum, and we're also going to declare an average of real. And now what I want to do is I want to say right in here sum equals sum plus grades I, j. We can say do a count. So every time you iterate past an element, it's going to count how many there are. I mean, in reality, 3 times 4 is 12. So we could just do it that way. But this might be more useful if, for example, we have we want to create a function to process arrays of different sizes. So I'm just going to go with that. And we would just say, I need to fix that. Sometimes these arrows just irritate me. We're going to have average is going to be equal to sum divided by count. And then we could just return average. I don't really see any need to, I mean, I guess there's like some validation we could do. But at this point, I don't really see any need to like initialize sum or anything like that, because we are definitely going to be adding values to it. It's not going to remain without a value. So that being said, let's move on to our last example, which is write a procedure that outputs the position of a specific grade in a 2D array. So maybe we have a grade like 97. We want to find the position in the 2D array. We're going to print out the first instance of that grade in a 2D array. So we could write a procedure. Find grade. And then our input will be an integer, grade. And then we're going to declare a row. And then declare a column. And then we will do like another 2D, we'll do for I. Okay, from 1 to 4, or rather 1 to 3. Basically what we did before. And then we can say if grades, we can look for that grade in our 2D array. So we can say if grades ij is equal to grade, so whatever our parameter was right here, then we can say row is going to be equal to I, so whatever index we're at, whatever row we're at, then column is going to be equal to j. You can end out if right here. I think it kind of makes sense to actually initialize these, just in case we never find, well, maybe we'll say row -1, column -1, so it's clear we didn't find anything. But just in case we don't actually ever find our grade, I think it makes sense to initialize it to avoid an error. Or initialize those two variables. And then we can say next j, next I, and end procedure. And we can output row, followed by a comma, and then column. And actually, if you want to print out strings, or if you want to print out strings that incorporate multiple variables, you can use commas to join them together. So comma, comma, I should have another comma here. And that's pretty much it. We could just call that by saying call find grade, and then like 97 or something like that. So that is 2D arrays. This is probably the most complex example I could think of while like concisely illustrating how 2D arrays work. So let's go ahead and let's move on to custom data types. What I'm going to do now is show you how to work with custom data types, which are one of the more exotic features of A-level pseudocode. I've never seen this in Python or Java, but I have seen this in the C programming language, which has a concept called structs, which is kind of similar to this. Anyways, we're going to start by creating a custom student data type with a name, student ID, birth date, and GPA. Create a record using this custom data type, store this in an array, and then calculate the average GPA of all the students in an array with the student data type. And then we'll talk about enumerated types after that. So let's get started. First thing I'm going to do is create a student data type. So I'm going to do type student, and then I'm going to declare a name variable, so name string, an ID, which is also going to be a string, a birth date, I guess, declare birth date, which is going to be just date of birth. It's going to be of a date type, which we haven't seen yet. And we're going to have declare grade point average, which is going to be a real. I mean, that is a decimal. And type. And basically, what we're going to do now is we're going to create a variable of this student data type. So we're going to say declare student1, and that's going to be of student type. No need to capitalize that. And then we're also going to create an array of student things, I guess student variables. And we can say declare student array. Array, so it's going to have 30 elements in it, 1 to 30, of student. And just to kind of show you how this works, we're going to just create we're going to start by creating just one student variable, or one instance of a student data type. And we can say student, that's going to be, well, we already created it, but we're actually going to initialize it. So initialization is the correct term. So we're going to say student1, which you created up here, dot name, and we'll just call that, I don't know, John Ali. And we'll have student1 dot ID, and that's going to be, I guess we'll say X387F or something like that. We'll have student dot birth date, and like dates are weird because like normally in any programming language, the date is going to be like the number of seconds from like 1980 or something like that. So it's generally going to be an integer. But in pseudocode, we just have like a straight up date, just like that. Like it's not a string. It's not like an integer that we would turn into a date. It's just a date. And then we'll just say grade point average is going to be 3.21. And I got to make that student 1, my bad. So that's basically how we would assign values to a typical student object, or typical student, I guess, variable. What I want to do now is to store this in the first index of the student array. So I'm just going to say student array 1 is going to be equal to student 1. So we're going to store a student in student array 1. Now, if I wanted to find the average of all the values in a student array, like let's just make the assumption that every student array, assume that the array is full, right? So we're gonna loop through it. We're gonna say declare, create a sum first. Declare sum is real. create a sum variable. We'll say for I 1 to 30, and then sum is going to be sum plus student array I dot grade point average. So we're going to assume that there is some student that is stored at every single index, and then we're just going to add whatever the grade point average is for that student to our sum. We'll do next, and then we can just do we could really just output sum divided by 30. That's pretty much it. Now this whole student thing, like I haven't worked with like structs, which is in the C programming language, in a while. This whole student thing is just a bit weird to me. Like I don't know why you wouldn't just use objects, because it's kind of the more common use case. You just create student objects from a student class and then do things that way. But it is what it is. I have seen questions like with regards to, I've seen questions that involve custom data types. They generally tend not to be too complex, so I wouldn't worry too much about it. The last thing I want to talk about is enumerated types. So I've seen this, I don't even remember whether it was C, I think it was like in like Ruby or something. But basically the way an enumerated data type works is we're going to create it like this. We're going to create an enumerated data type called status. And there's going to be 3 possibilities, right? So honors, pass, and fail. And these aren't really strings. Actually, I need to create this all the way up here. So we're just creating it like this. And then if we want to use that data type, we could say declare pass status. And that could be of type status, which we created up here. And then anytime we want to use that in a student, we could just say student1 dot pass status is going to be one of these 3 things. So honors, pass, or fail. Maybe we'll just say pass. And that's basically how enumerated types work. It kind of just like allows us to classify, to classify other variables. So I guess other variables with custom data types in particular, using a set number of classifications of categories. Additionally, I suppose this could also be used, I'm trying to think of like when you'd actually want to use this. I mean, you could have an array of just elements like this, and that could match up an array of IDs or names. So you have 2 arrays with matching and corresponding information. But I mean, yeah, I think mainly for categorizing objects is where you'd use this particular feature. Anyways, I just thought you should know about it and what it does and how you can make use of it. That covers custom data types. Now I want to talk about strings. So with strings, I'm not going to solve any particular exercises, because if we're purely talking about strings, the most important things are actually the methods that you can use to work with strings. So I'm going to go ahead and go over that now. I'm going to start by just creating a variable called sentence of type string. Now there are a few methods we can use. There may be more depending on what's given on your exam, but just based on the A-level guide, the first one we can use, well, we'll go ahead and actually just create a sentence here. We'll say, hello, my name is a myth. Now the first method we can use is going to be write. And write is basically going to give us, so we could say write sentence 5. And if we do, we'll create another variable here, declare new string. Basically what we could do is we could say new string is equal to that. And that would give us the rightmost 5 characters, which would be hello, and that would be new string. Or actually, no, right. Sorry, right, not left. So that would give us the rightmost 5 characters, which would be MITH dot. And yeah, that's basically going to get stored in uString. On the other hand, if we did left, that's going to give us the leftmost 5 characters, which is going to be hello. The next option is to use mid, which is going to give us the characters between positions in a string. So this means we're going to get every character from 5 to 8. So this is at index 5. We're starting at index 1. And so we're going to have 5, 6, 7, 8. So O comma space M. And that's what uString is going to be. Now, one of the more important ones is going to be length. So if we have length of sentence, then we're going to get, although I guess we can't really store that here. This is actually going to be an integer. So we'll just create another variable. We'll say declare sentence length. And that's just going to be an integer. I don't know why I did that. And then we could just say sentence length, which I spelled wrong in both cases, is going to be how many ever characters there are in the sentence. So 5, well, not even just including like blank spaces. So 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24. So sentence length would just end up being 24. Now the next one is actually not a function, but it's an operator. So if we want to join 2 strings, so let's say we have a sentence, and let's say we have name. It's going to equal John. We'll just declare that right up here. And we want to join both of these into a new string. We could just say new string is going to be equal to sentence and name. So this AND operator right here is going to be used to join both of these. So a result would just be something like, that would be our result from this particular line of code. Okay, so that about covers it for strings. Again, I don't really want to go too far in depth here because frankly speaking, it's just these methods and this operator that you're going to be using. There isn't much functionality in pseudocode beyond that. Like in programming languages like Python and Java, really a string is just an array of characters, which makes things a lot more, which gives you a lot more options because you can use loops and various other structures in order to kind of manipulate strings. But that's not the case in pseudocode, so I don't think there's any point in going beyond this. Let's move on to a more substantial topic, or a more substantial part of pseudocode, which is working with text files. So let's get started with our section here on text files. It's important to note that we're not only going to be working with text files, but also with something called random files that hold data or records of a custom data type. But we'll start with text files first. The first thing I want to do is I want to declare a variable called line of text or line text of string type. Now, when we work with text files, we iterate through them line by line. This is going to serve as a container for each line that we access in our text file, which is going to be called emith.text. Now, to access a text file, we can do open file, emith.text, and then for read. The for read part, well, for is always going to be there. Read just indicates that we're only going to be accessing information in the text file, not actually editing it. So let's say that I want to print out all the information in a text file called emith.text. I'm going to do while, not EOF, emith.text. And then I'm going to have some code inside my while loop. Now, end of file means, or EOF means end of file, meaning that this while loop is going to run until we get to the end of the emith.text file. That means traversing past the last line. Now, what we want to do here to actually read each line in the text file is we're going to do read file, emith.text, and then line text. This is going to do two things. First, it's going to take whatever line we're at, or in this case, starting with the while loop, it's going to take the first line of text and store it in the line text variable. Second, it's going to move as to the second line in emith.text. So read file actually moves our pointer, moves our position in a text file down by 1, as well as storing the contents of the current line in whatever variable we have here, which is line text. So line text should contain the contents of our current line. So if we want to output that, we can do output line text. Now what's going to happen is that each time we read file, that's going to move us further down the text file. So first time we'll read file, that'll move us to the second line. We'll output that, go back up to the while loop. We won't be at the end of the file. We'll go back down here, read the second line. That'll move us down to the third line until we hit the EOF point for emith.text. Now, if we want to count how many lines are actually in this text file, what we can do is we can declare a number of lines variable, integer, initialize that, and then we can just increment that each time we iterate past a line. Number of lines plus 1. Now, pretty simple, but what if we want to print out just the last 3 lines? So we do know with this line of code, if we were to output number of lines, then we would have how many lines are in the text file. What we need to do now is we want to close our file. Now, if read file iterates us through our text file, if we were to stop somewhere in the middle of running this while loop, then our position in that file would be somewhere in the middle of the file. It wouldn't be at the top. And if we continue to write code to access it, we would be starting at the middle of that file. However, if we close the file, then we go back to the top and we start fresh. We're not deleting the data, it's just refreshing our position in the text file to the top. That's why I closed the file. Now what I want to do is I want to run this loop again. I want to say while not EOF. And I want to be reading through the text file. Remember, I only want to print out the last 3 lines, but I still need this to iterate through my text file. What I'm going to do is create another counter. I'm going to say declare counter, integer, and then go ahead and initialize that, counter 0. And I'm going to be counting, or I'm going to be incrementing that one. It was counter plus 1. But what I want to do is I'm going to iterate all the way through this text file. But I'm going to say that if counter is greater than or equal to number of lines minus 3, then I can go ahead and actually print out what we're reading from the text file. So I can output line text. So this means that we're going to be going through the whole text file, but we're not actually going to print anything out until we're 3 lines before the end. Now, that wasn't too bad. The last thing I want to do is copy all the text in the emith.text to another file called destination.text. So I'm going to go ahead and get rid of all of this right here. And in order to actually work with destination.text, I need to open it as well. So I'm going to do open file destination.text. But I actually want to edit this particular file. So I'm going to do for write. Now, in order to actually write to this file, what I'm going to do is I'm going to get rid of this right here. And we're going to go through emith.text and we're going to get each line or basically each line of text line by line. What I'm going to say is if whatever line of text we get is not empty, then I'm going to write that. I'm going to say write file destination.txt and line text. So read file is iterating line by line, getting the contents of the current line each time. What write file is going to do is it's going to write to a line in destination.txt and then move to the next blank line. So they're both iterating through their respective text file. Now, what write is going to do is overwrite whatever already exists in destination.txt. At least this is what I think it does. It doesn't really say exactly in the pseudocode guide. But if we wanted to add information to destination.txt, so add to the existing contents rather than simply overwriting them, we could just change this to append. And then we would go to the end of destination.txt, write our line of text, and then just move on from there. I do want to make sure and point out that we do need to close both of these. So close file, emith.txt, and then close file, destination.txt. So now what we're going to do is we're going to talk about random files or data files as they're called. And I have this code right here from our previous section because in these data files, we're going to be holding a collection of records of a particular data type or variables of a particular data type. In this case, it's going to be the student data type. Now, what I've done right here is I've taken this declaration of the student data type from our previous section, and I've declared two variables of a student data type, initializing the first one. What I want to do first is I want to open a file or a data file, also called a random file, called emith.dat. What I'm going to do is I'm going to do open file emith.dat for random. And now that I've opened this file, what I want to do is I want to go ahead and actually go to a particular position in that file and get the data there. So unlike with text files where we're just kind of starting at the top and navigating downwards, when we're working with data files, we're going to be going to specific positions using the seek command. So I can do seek emith.dat, and then I can go to the 10th position. Now this may be empty, or this could be the 10th student that's stored in that file. Doesn't really matter. But to get the record there, I can do get record, emith.dat, and then student2. Student2 is empty before this, but given there's going to be a student record at position 10, I can just go ahead and get that and then store it in our student2 variable. Now if I wanted to put student1, this student1, at the 10th position, instead I could just do get put record and then student1. So working with positions in our data file, which really refer to some record. Now we don't usually work with, we don't really need to use loops, but let's say that we want to print out everything from position 5 to position 10. Or maybe from position 1 to 10. Remember, we're not really going to be starting at 0 because in general, indices in pseudocode start at 1. What we would do is we just say for pose 0 to 10, seek emith.dat, pose get record emith.dat student2, so store that record in student2, and then we could output some information from that, so we could just say student2.id, and then next pose. And last but not least, we need to close out that file. We'll do close file emith.dat. So that covers both text files and data files. Now, When I was trying to make this, I did look at a common A-level textbook from Hodder, I guess that's what it's called, and they had some functionality that I hadn't seen in the A-level pseudocode guide or on the exam paper. So I would say that in practicing working with files, definitely look at old exam questions and make sure to follow the pseudocode guide. If there's any functionality that you don't see here or on the pseudocode guide, then it should be given to you in that particular question in order for you to effectively solve or produce a solution. Anyways, we're done with probably the most substantial section, so let's move on. So for object-oriented programming, basically what I'm going to do is walk us through creating a car class. So create a class called car, and then a subclass called supercar. Now, object-oriented questions don't really show up on paper 2, but they do show up on paper 3. So it's worth knowing how to write code to describe a class, and then to instantiate an object from that class. So we'll start the command class car, and we'll specify some member variables. So private, we'll specify a make, specify a model, serial number, which is going to be an integer. I forgot to capitalize these. Honestly, the syntax for this is just like so weird that like it's almost unnatural for me to write code in pseudocode. Next, we're going to create our constructor, which is not going to have the constructor keyword anywhere. Instead, we're going to have public procedure new, and then whatever parameters we have for our constructor, which in this case are just going to be the car make, and then the car model, which are both going to be strings. And obviously the private and public keyboard are access modifiers. I'm not going to explain those in too much detail because again, the point is to teach you pseudocode, not actual programming. So I'm going to say make is going to be car make. So make coming from up here, car make from here. And then model is car model. Now our serial number is just going to be a random number between 0 and 99,999. So I can use this function rand 99999, which is included in the pseudocode guide and can be used anywhere. This returns a random number between 0 and this number right here. We will end that procedure right there, and that is our constructor. Now, if we want, we can add some class methods. I'm just going to add getMake. I'm just going to add the method definition. I'm not going to write the whole like function because I'm lazy. So we could do something like that. Then we would end our class with the end class command right there. So pretty simple. If we wanted to create a subclass, we could just do class supercar inherits car. Similar thing. We'll just have two methods. I guess here we'll say engine type and then fuel type. Another constructor, but here we need to take our we need to initialize if this is a subclass of car, we need to have the appropriate variables to initialize not only the parent class but then also our current class. So we're still gonna have car make and car model as our parameters. And we're also gonna have car engine type. Fuel type we'll worry about later, and we'll make that. Well, maybe we'll have a setter method there, or maybe we can make that public, but we'll deal with that later. Is a string as well. So in order to initialize, or in order to basically initialize our superclass, we're going to do super car make car model, which will access the constructor in our superclass, and then we can just do engine type is car engine type. And then we can do end class. Now to actually create an object, we're just going to create just to show how this works, we'll create a superclass object. We can just do Bugatti, new, supercar, and then we could just say Honda for the car make, Camry for the model, and then V8 for the engine type. Now we don't have to declare this anywhere. We just create this and this becomes a supercar object. And if we wanted to get the make, we could just do, or if we wanted to print it out, we could just do Bugatti dot get model. And that's it. So that brings us to the end of the pseudocode guide. I didn't mean for it to be this long. Ideally, you can just kind of go to the sections that are relevant to you. But pseudocode is an important part of the A-level exam, so I thought this was a guide that was worth making. If you want to see more videos like this, specifically helping you prepare for the A-level exam, please remember to like the video and subscribe to the channel. Have a nice day.